So I'm going to take a few minutes to finish that word problem we started in class, but that we didn't have time to complete. So to quickly refresh our memory, we've been given a profit function, and this profit is based off of the production levels of two different products, product A and product B. Product A is going to be represented with the variable x, so x represents the number of units of product A that are produced, and y is going to represent the number of units of product B that are produced. And we've been asked to figure out the number of units of product A and the number of units of product B that should be produced to maximize this profit. So we're basically going to follow that 5-step process for finding the second derivative test, and it begins by finding the derivative of the profit with respect to x, and then finding the derivative of this profit with respect to y, and finding critical values. So step 1, I'm going to find the derivative of the product with respect to x, then the derivative of the product with respect to y, and then I'll set both of those derivatives equal to 0 to find my critical point. So let's start with the derivative of the profit with respect to x. Okay, so going down the line term by term, the derivative of negative 4x squared with respect to x will just be negative 8x. Then I will have a 4y minus 0 plus 4 plus 0 plus 0. Okay. And now taking the derivative of the profit with respect to y, I will get 0 plus 4x minus 6y plus 0 plus 10 plus 0. Okay. So now that I've found both of those derivatives, I'm going to set them equal to 0 to find a critical point that will make both of these derivatives equal to 0 simultaneously. And as I can see, these derivatives both involve the variable x and the variable y, so I'm going to have to solve a systems of equations to find my critical point. And you can do this any way you feel comfortable. You can use matrices, elimination. I'm going to use substitution. So I'm going to take my first derivative equation, I'm going to solve it for y, and then I'm going to substitute that value into the second derivative equation I have here. So I'm going to start with my minus 8x plus 4y plus 4 equals 0. I'm going to solve for y and then substitute that into this equation. So I'll add 8x and subtract 4 on both sides. That'll give me 4y equals 8x minus 4. Then dividing through by 4, I get that y equals 2x minus 1. Okay, so now this value for y, the 2x minus 1, I'm going to substitute into this second derivative that has been set equal to 0. So I'm going to have to do some erasing. But if you need to, you can just rewind to see any of this old work. I'm going to erase this. And this y equals 2x minus 1, I'm going to substitute. So I have 4x minus 6y plus 10 equals 0. The y is being replaced with a 2x minus 1. So that'll be a 4x minus 12x plus 6 plus 10 is 0. So now I'll just combine my terms to clean this guy up. 4x minus 12x, that'll be a negative 8x. And then 6 plus 10 is 16 equals 0. Oh my goodness, I'm running out of space. I'm going to move over here. That would give me 16 equals 8x. So x must be 2. So x equals 2, that's the x-coordinate of my critical point. Now to find the y-coordinate for the critical point, I'm going to take this x value and replace it in, well, either of these equations. I'm going to replace it down here. So I can see that the y-coordinate is going to be 2 times the x-coordinate, which I'm claiming is 2, minus 1. So that would give me 4 minus 1, that would give me 3. So I found the x and y ordered pair that makes the derivative with respect to x equals 0 and the derivative with respect to y equals 0 simultaneously. So the ordered pair 2, 3 is my critical point because it makes both these derivatives equal to 0. So I'm going to record that over here because I'm going to have to erase this. So from step 1, I found that my critical point is going to be 2, comma, 3. Okay, so now I'm ready to move on to step 2 of the second derivative test, which is going to be to find my values of a, b, and c that later I'll use in my calculation. So I'm going to, I'll need these guys, so I'm going to erase this. And step 2, I'm going to have to find my a, my b, and my c values. So to find a, I'm going to take my function and do the derivative of x, and then that derivative with respect to x. And I'm going to find it generically, and then if there's any variables in that derivative, I'll evaluate them at 2 for x and 3 for y, and then we'll calculate a value for a. So taking my derivative with respect to x and finding its derivative with respect to x, I'm going to get -8 plus 0 plus 0. So this value for a is just a constant. It doesn't matter what inputs I plug in here. Like, I want to put in my critical values, but those inputs don't affect my a value. It's just going to be -8. Okay, so now to find my b value, I'm going to take the derivative of the profit with respect to x and then y. So I'm going to start with the derivative with respect to x and find its derivative with respect to y. So this first term is 0, its derivative with respect to y is 0. Then I have a 4, and then a 0. So again, I have a constant value for b. So the input of my critical point doesn't affect the value, it's just constant, it's 4. And then to find my value for c, I'm going to take the derivative of the profit with respect to y, and then its derivative with respect to y. So the derivative with respect to y, I'm going to find its derivative with respect to y. So that would be 0, -6, 0. Okay, and it's also a constant. There's no variable values in here. So inputting a 2 and a 3 doesn't change the fact that that derivative of the profit with respect to y and respect to y again is just -6. Okay, so I'm going to have to do some erasing. So I'm going to record these 3 values for my a, b, and c so I can use them later in my calculations. So let's do that. Had -8, 4, and -6. Okay. Because my step 3 says that I need to do my calculation of my a times c minus b squared based on the values I found in the previous step. So a is -8, c is -6 minus b squared. So that's going to give me a 48 minus 16, which will be 32. Okay. So I'm going to use this number along with the fact that my a value here is less than 0. My a is a -8, and that value is less than 0. And my calculation is greater than 0. Those 2 clues will tell me what case my function is falling into. So I'm going to look at my cases. Oh, which I conveniently didn't bring with me, so I'm doing this from memory. But if my calculation is greater than 0 and the a value is less than 0, that's going to bring me into case 1. And case 1 is when there's going to be a maximum value at that critical point. And the critical point was 2, 3. So step 4 is to figure out what case you fall into. And based on these clues, on these criteria, I'm in case 1, where I have a maximum value at 2, 3. So the only thing left to do is figure out how high that max is. So what's the maximum value that I get of my profit function when the number of units for product A is 2 and the number of units for product B is 3. So I'm going to plug these two values back into the original function to find the maximum value of the profit. Okay, so my profit at 2, 3 is, so I'm plugging these values into this original function, which is crazy long, so I'm just going to use my calculator, which hopefully, yeah, I brought, good, okay. So let's see, I'm going to do -4 times 2 squared plus 4 times 2 times 3 minus 3 times 3 squared plus 4 times 2 plus 10 times y, 3 plus 81, and I get 100. So the maximum profit is realized at these inputs, and that value is 100. But now I need to go back and interpret this answer in the context of the word problem. So when I'm looking at the word problem, I'm told that X and Y are given in, they represent hundreds per month, and that the profit is in thousands of dollars. So when I go to interpret this, I'd say that we realize a maximum profit of $100,000 if 200 units of product A are produced per month and 300 units of product B are produced each month. So I'd say something like, at a production level of 200 units of product A and 300 units of product B, we realize a maximum profit of $100,000. So there we go. We have answered our question. Both parts, we found how many of each product should be produced to maximize the profit and what the value of that maximum profit is. And if you have any questions, please don't hesitate to ask, and we will get them ironed out. Hope that helped.